Hello everyone. Following our educational clips, in these movie clips we are going to just much talk about Lego concept of modern construction. Nowadays, constructing a building has become similar to assembling a Lego system. Bespoke precast concrete elements are manufactured off-site with high precision, transported to site and installed in their designated positions. On the right-hand side short clip, I tried to give a simple overview of how modular construction works using precast concrete fabrication. As shown in the diagram on the left-hand side, the modular construction process is mainly divided into two stages. First, the site foundation works. This includes the foundation casting, starter rebars, and the initial setting out. That part is completely outside of the scope of this discussion, so I'll focus mainly on the precast side. The second stage is the installation of the precast units themselves. This includes the internal solid panels, external sandwich panels, and the roof dummy decks. What makes this construction method interesting is that most of the structural elements are manufactured in a controlled factory environment before being transported to site for installation. That helps improve quality control, speed up construction, and reduce a lot of the on-site work compared to traditional construction methods. This slide shows one of the internal wall panels from our installation schedule drawings. The panel weighs around 1255 kg with a maximum length of 2425 mm and a width of 1528 mm. It's a relatively compact unit, but it's packed with details, and from a QA perspective, every single one matters. First, all dimensions of the mold need to be checked carefully. What makes this unit tricky is that the finished face is actually cast at the bottom of the mold. That means all the embedded items are fixed from the top side of the mold instead. Because of that, the carpenter can't just follow basic shuttering work. He almost has to work like a technician, calculating positions, offsets, and additional allowances for mold wall overlaps to make sure everything lines up correctly after casting. Second, these wire rope boxes are designed to connect a perpendicular panel to this unit. A rebar passes through the wire loops, and then the recess gets filled with grout to create the connection between both panels. Third, the through-hole pipes are used for full-length rebars connecting the panel back to the foundation. After installation, the pipes are grouted properly to achieve structural rigidity and secure the panel into the foundation system. Fourth, these two 135 mm cutout locations are reserved for the protruding rebars coming from the lintel above. The lintel sits across this panel and the adjacent one, with starter bars extending into these pockets, which are later filled with grout. Fifth, the dashed lines along both edges represent the chamfers. Architecturally, they give a clear finish after installation, but honestly, I believe their biggest advantage is protecting the corners from chipping compared to having sharp straight edges. Six, these two sockets are used for temporary props during installation. They help stabilize and align the panel on site while also giving the installation team a bit more tolerance for adjustment. And finally, the four CFS flat plate lifters used for demolding and landing the units safely inside the factory. From this diagram, like all the other fabrics that we have discussed, three stages are for QA checks. Mold inspection stage, which I have tried to introduce in the previous slide. The second stage is reinforcement inspection, So the reinforcement cage is inspected before installation to make sure it fully complies with the structural drawings and required concrete cover. And after the mold is ready and the reinforcement has been inspected, the final pre-pour inspection, and it is the last chance to find any defects before casting. After placing the reinforcements inside the mold, alignment and concrete cover are checked once again before final approval. The wavy anchors and their additional reinforcements are inspected carefully to ensure proper structural continuity between connected panels during installation. The demolding lifting systems and embedded plate assemblies must be securely fixed and properly reinforced to withstand handling and lifting stresses. And finally, the M16 threaded sockets are checked for position and alignment, since they later be used for temporary props during site erection. These three sets of pictures showing those three QA check stages. The left hand picture shows the mold check before putting the steel. The mid picture shows the reinforcement has been installed inside the mold, and the third picture, which is the right hand picture, shows that the steel cage has been set up inside the mold. All the embedded items, including flat plate lifters, including wavy lifters, including the M16 threaded sockets, including the wire rope boxes, have been installed on the third one. Thanks to you all for chasing my video clips on QA checks on precast fabrics. Here are more details for further contact, and hope see you with my next clip. Bye.